Hey everybody, welcome. This is part 2 of the 4.1 notes for 4.1. So let's go ahead and keep going where we left off. You might have to turn to the next page in your note packet. What we're going to look at here is what happens with a stretch or compression. So when A is 1 or -1, we say that there's no stretch or compression. So if we're going to graph simply y equals x squared, that's where you're going to have that vertex point at 0, 0. When we go over 1 to the right, we go up 1. When we go over 1 to the left, we go up 1. If we move over 2 from the vertex, we're going to go up 4. And that's both to the to the right and to the left. If we were to go over 3 from the vertex, we would have to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, that would be on both sides because of symmetry. Now, there are going to be situations where there will be a number in front. So this box got screwed up. But in this case, if we have y equals 2x squared, a is 2. So that means there's going to be a stretch by 2. So your vertex is still going to be at 0, 0. Now when we go over 1, we're actually going to go up 2 times 1. Okay, we normally go up 1. The stretch is 2, so we do 2 times 1. And that's going to be left and right. Normally, when we go 2 from the vertex, we go up 4. When the stretch is 2, we have to go up 2 times 4. So we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, that's on both sides because of symmetry. So the parabola will look something like that. If we look at the next example below, where a is 4, that basically tells us the stretch is 4. So starting at 0, 0, the origin, when we go right 1, we're going to go up 4 times 1. So 1, 2, 3, 4. That's left 1, up 4 as well. Now, if we were going to go over 2 from the vertex, we'd have to go up 4 times 4, which would be off this graph. So we're not going to include that point. All right, so a greater than 1 is going to be a stretch. If a is a number between 0 and 1, like 1/2, it's compressed. And essentially what that means is you still have the vertex at 0, 0. When we go over 1 to the right, we're going to go up half of 1, which is 1/2. And we do that in both directions. If we go over 2 to the right, we go up half of 4, which is 2 in both directions. And the graph would look something like this. So one thing we want to kind of keep in mind is when the graph is stretched or compressed. All right, essentially, you want to think about it as with any stretch or compression. All right, so with a stretch or a compression, all right, from the vertex, you're going to go over 1, and then you're going to go up a times 1. So whatever a is, you multiply that by 1, and that's what you go up. From the vertex, when you go over 2, you're going to go up a times 4, because normally it's over 2 up 4. A is going to stretch that. If you were to go over 3 from the vertex, you would go up a times 9, right? And then that pattern would just kind of continue as you went over. But normally when you go over, you'll go over 1, then over 2, and that's usually enough points to graph your problem. All right, let's take a look at a couple more examples, and then that should do it for the notes. All right, looking at number 1 here. The 3 in front is a stretch. Now, pause the video and try this on your own before I finish this. So this 3 in front is going to be a stretch by 3. The plus 2 inside the parentheses is going to go left 2, and the minus 5 is going to move the graph down 5. So this is when I like to graph. once I've identified the transformation. So from 0, 0, I'm going to go left 2, down 5. Because of the stretch, instead of over 1, up 1, I'm going to go over 1, up 3 times 1, which is 3. And I do that left and right. Instead of over 2, up 4, I have to go over 2, up 3 times 4, which is 12. So over 2, up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to put me there. So this is what that graph is going to look like. All right, now identifying those things we did earlier, the vertex is going to be at -2, -5. All right, that point we plotted right here, that's our y-intercept. So that's going to be 0, 7. This graph is going to have a minimum of -5. The domain is all real numbers. The range, y is greater than or equal to -5. The axis of symmetry is that imaginary vertical line passing through our vertex. So right there, it's x equals -2. All right, looking at example 2. Again, pause the video, try it on your own. So the negative in front is a reflection. The 4 in front is going to cause a stretch by 4. The x minus 3 is going to move the graph right 3, and the plus 6 is up 6. And those are the same transformations we talked about in chapter 1. So from 0, 0, we're going to go right 3, up 6. All right, there's 2 things now that are going to help me get to the next point. It's reflected, so we're going to go down, and it's stretched by 4, so you go down 4 times what you normally would. So it's right 1, down 4. Which is coming from 4 times 1. That's the same thing as when we go left. If we were to go left 2, we'd have to go down 16, which is 4 times 4. Chances are that's not going to fit on the graph, so just sketch the graph from there. We have a vertex, right 3, up 6, so that's 3, 6. Now, our y-intercept in this situation, we don't see it on the graph. So this is when we're going to have to plug in 0 for x. So right up here, I'm going to take my equation, y equals -4, 0 minus 3 squared plus 6. All right, 0 minus 3 is -3. If I square that, I'm going to get 9. And then I'm going to add 6. That's -36 plus 6, which combines to give me -30. So my y-intercept is going to happen at 0, -30. So that's one thing to remember. You can always find the y-intercept by plugging 0 in for x. This graph has a maximum of 6. Domain from left to right is all real numbers. The range, this graph goes down forever, but it doesn't go beyond 6, so y is less than or equal to 6. And our axis of symmetry is x equals 3, and that's coming from this vertical line. All right, a couple more examples and then we'll call it good. So for number 3, again, pause it, give it a shot on your own. The 1/2 in front is a compression. So it's compressed by 1/2. Plus 4 is going to move it to the left, so we're going to go left 4. Minus 1 is down 1. So from 0, 0, left 4, down 1. The compression tells me to go over 1, up 1/2 of 1. So that's over 1, up 1/2 in both directions. Over 2, up 1/2 of 4, which is 2. So that's going to give us, a wider parabola that looks something like that. Our vertex is at -4, -1. Again, for the y-intercept, I don't really see it on my graph, so I'm going to go ahead and plug in 0. So when I do that, it's y equals 1/2, 0 plus 4 squared minus 1. All right, 0 plus 4 is 4, 4 squared is 16. 1/2 of 16 is 8, and 8 minus 1 is 7. So that's where the graph would cross the y-axis, is up 7. This graph has a minimum of -1. The domain is all real numbers. The range, all right, it doesn't go down forever. It starts at this point. So y is greater than or equal to -1. And the axis of symmetry, x equals -4, which again is this imaginary line that divides the graph in half. All right, we got one more to do real quick. Again, pause and try this on your own. So for this one, we've got a negative in front, which is a reflection. We have a 1/3, which is a compression. So we're compressed by 1/3. And that's it. There's nothing else being done. So our vertex is going to stay at 0, 0. Now, instead of over 1, up 1, the reflection tells us to go down. The compression tells us to go 1/3 of what we normally would. So I'm going to go right 1 down 1/3 of 1, which is about there. And that's true for that. If I go right 2, I'm going to go down 1/3 of 4. Well, that's 4/3, which is 1 1/3. All right. The point that actually you can plot easy when it's a compression by 1/3 is over 3. Because normally over 3 is up 9. 1/3 of 9 is 3. So in this case, because of the reflection, we're going to go right 3, down 3. Left 3, down 3. And this is the general shape that that graph is going to have. Our vertex is going to be at 0, 0. That is also our y-intercept. This time the graph has a maximum of 0. The domain from left to right is all real numbers. The range, y is less than or equal to 0. And the axis of symmetry, that imaginary vertical line, is x equals 0. All right, hope you guys found these videos helpful. If you have questions, make sure you ask them in class and we'll go over those. So good luck on your homework, and I'll see you guys next time.